February 15, 1961. Idlewild International Airport, New York, USA. Sabena Flight 548 was preparing for departure. A total of 72 people boarded that day, including 61 passengers and 11 crew members. They were about to begin a long transatlantic flight from New York to Brussels, Belgium, with a flight time of about 8 hours. Operating this service was one of the most advanced jet airliners of its time, the Boeing 707-300. In the early 1960s, this aircraft symbolized the jet age. It was powered by 4 Pratt & Whitney GT4A turbojet engines. By the time of the accident, the aircraft had logged 3,038 flight hours. Inside the cabin of Flight 548 was a special group. Members of the U.S. national figure skating team. 18 young athletes and their coaches. Judges and family members were traveling to Prague, Czechoslovakia, for the World Figure Skating Championships. As passengers took their seats, the cockpit crew were also making final preparations. The captain, 50, was in the left seat, Louis Lambrechts, with a total of 15,384 flight hours. In the right seat was 48-year-old First Officer Jean Royot. He had previously served as an Air Force pilot, flying aircraft such as the DC-6 and DC-7, with 16,231 flight hours. 2 more crew members were in the cockpit, navigator Jean-Marie Can and flight engineer Lucien Duver. At Idlewild Airport, everything went smoothly for departure preparations. The aircraft's takeoff weight was 119,500 kilograms, including about 50,000 kilograms of fuel. According to all technical records, the aircraft was in very good condition. At 0-100 Coordinated Universal Time, the crew received takeoff clearance from the tower. The pilots advanced all 4 powerful engines to takeoff thrust. The Boeing 707 accelerated down the runway and then lifted off from Idlewild Airport, heading for Europe. What awaited them next was around 7 hours of stable cruise flight. In that era, jet airliners normally flew at higher altitudes than piston aircraft, in what were known as flight levels. These altitudes were strictly assigned air corridors. Flying in thinner air not only reduced drag and saved fuel, but also avoided most turbulence. For passengers, this was almost an exceptionally smooth and comfortable journey. But in the aircraft's technical log, several troubling entries were hidden. At the time, those records did not receive enough attention. Just 1 week before the accident, during a test flight on February 9, 1961, the crew reported some abnormalities. The horizontal stabilizer trim actuator felt heavier than usual to operate. There was also another more concerning issue. The aircraft showed a noticeable tendency to roll right at cruising altitude. The crew also found that the left wing spoiler, used as an air brake and flight control aid, stood about 1 inch above the wing surface. This may have indicated that a hidden defect was in the flight controls, and that defect was waiting to be triggered at a critical moment. Flight 548 remained generally stable over the Atlantic. As the flight neared its end, the crew began preparing for landing. Weather conditions over Brussels were good, with visibility of about 3,500 meters and a cloud base of about 2,000 meters. For a standard instrument approach, these were quite favorable weather conditions. But at 9:59 a.m., something unusual happened. Flight 548 suddenly stopped radio communications. The last transmission was only a routine report. After that, the crew never replied again. In the next few minutes, ground controllers repeatedly called the aircraft, but only silence came over the radio. Losing contact suddenly during approach usually means the crew is facing an emergency requiring full concentration. Pilots do not go silent without reason. When they fall silent, they are often fighting danger. At around 10 a.m., the aircraft finally appeared within sight of the airport. On approach for landing on runway 20, the pilots lowered the landing gear and began descending. It seemed the flight was about to end safely. But at that moment, an obstacle suddenly appeared on the runway. A small aircraft had not yet cleared the runway area. The tower immediately instructed Flight 548 to go around. A go-around is a standard procedure, and one pilot's practice repeatedly. Increase engine thrust, retract the landing gear and flaps, and climb back to altitude before making another approach. But for Flight 548, this go-around became the start of the disaster. After the engines were advanced to takeoff power, the Boeing 707's attitude became abnormal. It did not climb smoothly as expected, but suddenly began a sharp left turn. Witnesses on the ground watched in horror as the large airliner began circling above the airport. One turn, two turns, three full 360-degree circles. While the bank angle kept increasing, the aircraft briefly climbed to about 1,500 feet, or 457 meters. But that was no longer normal flight. It was more like a final struggle. The aircraft's speed dropped from 215 knots rapidly to a dangerous 145 knots. That is, from 398 kilometers per hour to nearly 268 kilometers per hour. To keep such a large jet airliner flying at such a low speed required extremely precise control, but by then control was gone. Witnesses described the aircraft's final moments this way. The nose suddenly pitched sharply upward, almost vertically nose up, as if trying to break free from an invisible loop, a classic stall. As lift suddenly disappeared, the aircraft rolled sharply, and then entered a steep spiral, diving toward the ground. At 10:05 local time, Sabena Flight 548 crashed in marshland about 2 kilometers from Brussels Airport. The impact was nearly vertical. The massive force and the explosion that followed completely destroyed the aircraft, leaving only scattered wreckage. All 72 people on board were killed instantly. The falling wreckage also killed a farmer on the ground and seriously injured a worker. The investigation was led by Belgian authorities, with support from ICAO and the U.S. Federal Aviation Administration. The investigation was very difficult, because the aircraft was almost completely destroyed by fire. In 1961, black box technology was still very limited, and could only record a few basic flight parameters on metal tape. Yet it was those limited data, together with a careful study of the wreckage, that gradually led investigators to the key clues behind the tragedy. After the mysterious crash of Sabena Flight 548, the breakthrough came from the tail section, where investigators found the horizontal stabilizer trim mechanism. To understand how serious this was, it is important to know that on the Boeing 707, the horizontal stabilizer was not a small component, but a large control surface, responsible for longitudinal balance. That is, controlling nose-up and nose-down attitude. Investigators eventually determined that the stabilizer actuator had jammed at 10.5 degrees nose-up, almost the maximum nose-up position. At such an angle, the aircraft could hardly maintain level flight. It would keep pitching up, as if trapped in an endless loop. Inside the stabilizer drive mechanism, investigators found moisture, ordinary condensation. In the freezing temperatures at altitude, that moisture turned to ice. But that was not the only problem. Inside the same mechanism, there was also a thick grease. Research showed that at very low temperatures, this grease could become as sticky as glue, causing the ball bearings to seize, and preventing the whole mechanism from moving normally. Investigators also found sheared rivets in the spoiler control system. The spoilers are control surfaces on the wings, used for speed reduction and roll assistance. This damage suggested that at some point, the spoilers may have moved asymmetrically. One side may have deployed on its own, creating a strong rolling force, while the pilots were unable to fix it effectively with controls. With these findings, investigators tried to reconstruct what happened in the cockpit in the final minutes, when the captain and first officer were told to go around and advance the engines to maximum thrust. The jammed stabilizer, together with the sudden increase in thrust, caused the nose to pitch up uncontrollably. The pilots likely realized very quickly that normal elevator input could no longer correct the attitude. In that situation, the only option they may still have had was to use asymmetric thrust for control. By increasing power on one side and reducing it on the other, they tried to counter the rolling tendency and bring the aircraft back into balance. The 3 full circles above the airport were likely the result of their desperate effort to keep control. And with the technology available in 1961, there was no help from modern flight control systems, and no clear procedure for handling such a failure. The crew had almost no real chance. Once the speed dropped below the critical point, the laws of aerodynamics ultimately overcame human effort. The crew had already done everything they could, but the sudden failure, the limited time, and the difficulty of identifying the problem quickly made saving the aircraft almost impossible. It should be noted that this was only one of the official conclusions, and over the years this explanation has been questioned many times. The exact cause of the crash has never been fully established. In the end, however, the disaster led to a series of major aviation reforms. After the accident, Boeing issued a series of urgent technical bulletins requiring all Boeing 707 aircraft fix the horizontal stabilizer now, drive mechanism, as well as the spoiler system. At the same time, airlines were also required to install new mechanical heating to prevent these linkages from icing up at high altitude. In addition, maintenance procedures were comprehensively revised to prevent moisture from entering these critical parts. This tragedy not only changed aviation safety rules, but also had a profound impact on sports, because nearly the entire U.S. national figure skating team was lost in the crash. Afterward, the sports world introduced a strict safety rule. No national team is allowed to have all members travel on the same flight. They must be split across different flights to reduce the risk of a total loss. To honor those who died in the crash, the United States established a figure skating memorial fund to support and develop a new generation of skaters. With the help of this fund, the U.S. later produced a number of outstanding figure skaters, including the legendary champion Peggy Fleming. On February 10, 2001, in Berg, Kampenhout, Belgium, near the crash site, a memorial was officially unveiled to honor all victims of the disaster.